Hello everyone. Welcome to our presentation. We are going to introduce you our work. The secret codes tell the secrets. Our presentation is divided into four parts. The first part is about ourselves. The second part is the topic, secret codes. And the third part is the vulnerabilities we have identified, which are related to the secret codes. And the last part, we're gonna leave around 10 to 15 minutes for question and answers. So first of all, about ourselves, my name is Guangdong, and I was in Singapore, but now I moved to the University of Queensland in Brisbane, Australia. And my research is on mobile security and protocol analysis. The left-hand side, Zhang, my partner, he is currently the senior Android security researcher from ByteDance, and his research direction is Android security and payment security. So this is actually the fourth or the fifth time that we give a talk in HITB, but it's a pity this year we cannot see you guys in Singapore, and so we have to meet all old friends. So the second part, the secret codes, which is the topic of this work. So I believe you have such an impression in your dialer. You don't have to every time. You don't have to input your mobile number here or phone number here. What you can do is you can input something start with star sharp and a code, then sharp star. So this is called secret codes, and sometimes it can be referred to as hidden codes, so or security codes. So if you show those stuff, they actually mean the same thing. So the secret codes in Android are well known by engineers and geeks, but previously people are just use them for testing or just for fun. And we're gonna reveal that actually security codes has lots of security implications, and this haven't actually been well studied and even have not received enough attention. But through today's talk, we're gonna show you that those secret codes actually expose many attack surfaces, which can be easily compromised by the attacker and to obtain the system privilege. So here is a very famous incident in 2017. A security researcher pointed out that from some Android devices, so here we omit the name of the brand, it's a brand with a lot of users. Okay, so the security researcher pointed out that such Android devices have a backdoor in an engineer mode app, which can lead to the root exploit. And later, the Qualcomm VP of Product Security Engineer, Alex, stated on Twitter that the engineer mode app was not authored by Qualcomm, but others, maybe the manufacturers, who built it on top of previous testing application. So this incident raised a very big concern. So it was reported on the website, and later in a Twitter, researcher posted that actually through the secret code, you can actually access the manual tests such as a GPS test and the root status test. And further, we're gonna reveal that actually a lot of more tests can be done through the secret code. For example, the fingerprint test. We're gonna introduce you later in this presentation. So we want to have a discussion on the Android permission system first before we enter secret code, because this is gonna related. This is actually explain why the secret code can cause security problem. So we know that after Android 6, Google has tightened Android permission. For example, previously the permissions is granted to the applications at the installation time, but now Google allow granting at runtime, which means whenever application wanna access sensitive data or sensitive service, such alert will be prompt to the user, and through this user can choose to grant or deny the access. And since Android 10 and 11, the Google also give users interface to specify fine grant permissions for sensitive data and services such as location, microphone, and camera. So when we're talking about the access control system, one thing we need to make sure is whenever, when you protect a particular sensitive object, the permission policies must be enforced consistently and globally. So what do I mean by this? Let's say you have very sensitive service, and through the normal user interface, you have very comprehensive control on the authentication and authorization. However, if your access control system provides some special entrance, so that the user or developer or anyone through that entrance can access that functionality, then this is a violation of the existing permission policy. And to some extent, this kind of entrance can be regarded as a backdoor. So here, I want to show you a very quick example. So in this one, you can notice that through the normal interface, through the actually the settings application in the Android phone, if you want to change the language of the system, you will need to input a PIN number or pattern log. So basically, you need authentication to do that. However, if you do it through the secret code, actually you don't have to input any authentication or authorization stuff to prove your identity. Okay, so let's look at this demo. Yeah, so here is, when you do this through the settings app, you need to input the pattern or input the PIN. However, if you do this through the secret code, so this is a secret code you can use to change the language setting. Okay, so if you do it through secret code, what you can find is you don't need the pattern log, you don't need the PIN code to change the language, right? So here actually is something I discussed in the previous slide. You have the normal interface to change the language, and this interface will be enforced by authentication and authorization. Basically, there is a safeguard to this functionality. However, if you use a secret code, this safeguard can be bypassed. Okay, so this is a violation to the Android permission systems. Sorry. Okay, so now I want to have a very quick introduction on secret codes. The secret codes in Android refer to the codes we can access hidden features or secret menu, such as display information or to test hardware and software. And these codes are usually used to provide a faster way for the manufacturers. So be careful, here is manufacturers. That means this secret code is used only in a factory. So this code provides a fast way for the manufacturers to verify, their smartphone and tablets are working as intended. For example, if you want to look at your IMEI number of your mobile phone, what you need to do in Android is you go to setting and about phone and check the IMEI number. However, through the secret code, you can simply dial this code to get the IMEI number. Okay, so what will happen when this secret code is dialed in a dialer of your phone? So basically, the system setting or system dialer app will trigger this code. So in this code, you can find that it broadcasts intent, which include the secret code action. So later I will show you what is action, and then plus with a data field which include the actual secret code. Okay, so this thing will be broadcast so that any application which listen to such type of intent will get this constructed intent here. Okay, so you can actually create your own secret code. What you can do is you can just put these lines of XML code into the Android manifest.xml. So basically, it registers a broadcast receiver for this application. You can find that the action, which is the one I just mentioned in the previous slide. The action is set to Android.provider.telephony.secret code, and the data field is the secret code you want to specify. Okay, then in your application, you just implement such a broadcast receiver so that whenever this secret code is dialed in a dialer app, this broadcast receiver will be invoked by the system. So you find here, this invocation is actually through the intent. It's not a direct call in a program. So this provides attacker opportunity. So if you're familiar with, how the application, how the ICC works in Android, I believe you understand what I'm talking about, which means this thing can actually be done automatically instead of require the user to input the secret code through the dialer app. So what you can do, first thing, you can just construct such an intent with the dialer action, and the secret code. Then you can just call the start activity. So once you call this intent will be sent to the one who is listening to this intent. Similarly, you can construct a broadcast to do this. So I hope you find the trick here is the attacker doesn't have to actually input anything through the dialer. It can construct such application so that it can automatically, by automatic I mean it doesn't need the victim user's interaction. It can automatically call the application which dealing with these secret codes. Okay, so why this is risky? Why is this dangerous? Basically, those secret codes come from those factory installed application, such as the engineer mode or WT secret code manager, and some are from those embedded applications such as the contacts, calendar, and even the calculator. So the special thing for those applications is that they are either built-in or system side, which means they own very high privilege that different from the normal application. Basically, there are those applications with the highest privilege in the mobile phone. Okay, so what does that mean? That means once those secret codes can activate those applications to do some actions, those actions actually high privileged. Through a normal application, definitely those actions cannot be performed, right? So you can find that those secret codes can provide a broad attack surfaces and cause severe security impact to the users. So as evidence, if we grab this is the action, the interaction name I just showed you. If you grab this in the devices, you can find that all the applications with this action, basically all the applications which handle the secret codes are actually in a framework directory, which means there are those applications with a system or signature level of the privilege. Okay, so we categorize those secret codes into 6 categories. So the first one is the info code. Basically, through the secret codes, it's possible to get some sensitive information. For example, the *#06#, the one I just mentioned, display the IMEI code of the mobile devices. The second type is a backup codes. So you can find one here, one long one, which do a quick backup to all the media files in a mobile mobile devices. And the third category is the testing codes. So this is used for tests. Basically, a lot of vulnerabilities is related to the secret codes in this category. So later I will show you that. An example for those testing codes, secret codes, is this fingerprint test. Okay. The first category, the configuration codes. So basically, it can do some configuration on the phone. For example, can do a complete wiping of the mobile devices. And also it can reinstall the the firmware of the mobile device. The fifth category, the developer codes. So basically, it provides several secret codes can be used by the developer to fast reach a position during the development process. For example, system dump mode. And the last mode, USSD mode, is related to the phone call. For example, these 2 secret codes can be used to turn on or turn off the call waiting. So the purpose we list those secret codes to you is that we want to show, actually those security codes can do a lot of high privilege actions. Okay. So next part, we're going to introduce you the vulnerabilities we identified, which are related to the secret codes. So as a very quick summary, we identified 5 types of the vulnerabilities. So what we will do in this part is, I will first give you a very quick brief on those 5 categories of vulnerabilities. Then Qing is going to give you a demonstration and explanation on a demonstration. Okay, so the first part, the first type of vulnerability is kind of the system reset bypass vulnerability. So what do I mean by this is, if you want to do the formatting and factory resetting on your Android device, it's very sensitive, right? It's very risky. It usually requires you to do the authentication. However, we find that through the secret code, actually, now you can bypass the authentication part. And this vulnerability, is the most severe one we find, and it influence basically all OEMs devices. And fortunately, the problem is gradually fixed by manufacturers as the Android OSs are upgraded. Okay, so later we'll give you the demonstration. The second type of vulnerability is the something related to using engineering mode to change the language settings, like in the first few slides I introduced. And also some vulnerability allows to turn on cameras without users users authorization. So this is very dangerous, right? Because it basically leaks users' privacy and also the information of user surroundings. So it's very privacy sensitive. And third category, we find that some devices might, once the application is caught by secret codes, they may just lock the pin through the logcat. So later we will show you the examples. The fourth category is to some devices allow to use the engineering mode to reboot the phone into Qualcomm's kernel FFBM mode, which is a very dangerous mode. Later, I will explain it to you. The last type of vulnerability is to use the engineering mode to reset and disable the fingerprint lock. So basically, it's to bypass or to disable the fingerprinting authentication system in your mobile phone. Okay, so next we're gonna give you a demonstration for each category one by one. So I will invite Qing to give you the first demo. Hi, Qing.
Hello everyone, I'm Zhang Qing. Here I will show you several vulnerabilities about the secret codes. The last one was found a long time ago, assigned this V number. From this video, we can see if we want to reset the phone from setting application, it needs your authentication. But if we type the secret code directly in the dial UI, it does not need anything. Okay, let's see the first video demo. Okay, the second demo on the right can show the inconsistency about the permission more vividly. We reach the engine model interface and find that there is a reset phone function on the first page. If we click it, it pops up a dialog which is needed to input the password. Then we go back to the first page to click the engineering test and select the third tab. Here we can see another reset function, from where it does not need any authentication, but pops up another dialog, which says the config file is not existing. We try to attach an empty config file in the SD card and click the reset button again. The phone is reset. The OEM is applying a CVE for this one. Okay, let's see the video demo. Okay. Let's say another page. Let me show you a demo about the leaking lock screen pin number. It happens in the same place, just the last one. If we type the password to reset the phone, the password will be printed in the logcat. What's more, at this moment, the user's PIN number is removed. Because of this activity is spotted, there is existing the third vulnerability. An attacker can use any application to invoke this activity to induce the user to remove his password. Okay, let's see the video. Here we go back, we find the password is removed. Okay. Let me show you another about leaking user's password demo. This demo is also about the leaking user's Wi-Fi password. We find that there is a supported broadcast receiver in the engineering mode, which can receive the connection Wi-Fi broadcast to connect to Wi-Fi, in which it prints the SSID and the password to the logcat also. Okay.
Okay, thanks, Qing. So next part, I'm gonna give you a very quick introduction to vulnerabilities related to the engineering mode. So just now we mentioned that secret codes can change the phone into engineering mode, and this is very dangerous. And why? I'm gonna introduce you soon. So before that, I will quickly introduce you the FFBM mode, which is kernel mode called fast factory boot mode. So this mode is developed to be used by the manufacturers, and is used to facilitate fast reboot and testing in a factory. So it only provides very minimal user interaction, so that it can be reboot very fast compared with the normal Android operating system. So on the right hand side, this flowchart gives you a very quick introduction on the booting process into the kernel FFBM mode. So you can find that once the kernel is started, and it will execute the init process, and here instead of boot into the Android mode, which is more expensive, more heavy, and we can choose to let the phone boot into the FFB mode during the development in a manufacturer side. So after the problem is that after entering into the FFBM mode, the user has to quit it and re-enter the normal Android mode. So this is the 3 steps. The user can do that. But the problem is the second step is actually very, very risky. So basically, before quit the fast boot mode, you need to erase the MISC partition. So we know that there are lots of crucial system configuration information stored in a MISC partition, and also like CID or USB configuration, and even some hardware configuration are all stored in this partition. So it's safe to remove it, to clear this partition in a factory, because there's no any sensitive data stored. But the problem is, once the phone is already used by the user and some information are already put in that partition, then if this partition is erased, there will be some problem. For example, the phone maybe, after you reboot into the normal Android mode, maybe it cannot function as normal. Okay, so secret codes can actually enter this, engineering mode, which is on the left-hand side. And if the user, if unsuspecting user just choose to reboot to the FFmpeg mode, the problem which I mentioned in the last slide will happen. And the last vulnerability I want to talk about is regarding the fingerprint checking on a fingerprinting-based authentication system. So basically, through the engineering mode, you can enter the fingerprint test. But the problem is, once you do the test, the test, right, is a test. It shouldn't pose any side effect to the normal side, right? But the problem here is, if you do such test in the engineering mode, the operation you do on the fingerprint may affect those fingerprints in a normal mode. So here is some complaints we find on the forums posted by different users. So they all complain one thing. They did a fingerprint test in the engineering mode, and then they find that normal fingerprint-based authentication is disabled or dysfunctioned. Okay, so here is how this will happen. So once you enter the engineering mode, and if you choose the fingerprint test, and this is a screen where you can, record your new fingerprint, but whatever you do here, it's gonna erase the stored fingerprints. So basically, this is bypass authentication bypass attack, right? So that is all about the 5 categories of vulnerabilities we identified in this work. And before I start answer your questions, I want to give you a very quick introduction on how we identify those vulnerabilities. So basically, we built a fuzzer to do this. And what we do is we get the application list in a mobile device. And then through the context resources, we can get their Android manifest.xml. And through a very simple parsing, we can find those applications which listens to the action, the action name of the the secret code intent. So the one I showed you in a few slides before. So once we get this, we know which applications actually handle the secret code. So what we do is, we get the code name, and those numbers, those string 1122, those stuff. We get the name from the manifest. Then we can build a proof of concept to test application. Okay, so this is how we have identified the vulnerabilities we reported in this presentation. Okay, so we come to the summary of this work. Basically, we want you to take away a few recommendations. The first recommendation, when you design and implement access control system, make sure it's consistency. Basically, for a particular sensitive object, so all the paths with this object must be enforced the same access control policy, right? So the basically the access control must be consistent. And the second is just for the developer to make sure you remove all the such secret codes or the backdoors, because definitely they will be identified by the researchers. And last, remove all the functionalities for testing in factory. For example, the engineer mode app. Basically, they are just used to for the efficiency in the factory. There is no sense they need to be given to the normal users. So what we suggest is, all the manufacturers should consider removing those functionalities before their mobile devices go to the market. Okay, so that is all for this presentation, and thank you so much for your attention. And next part, we're happy to answer your questions. Thank you.
Okay, so we've got 3 questions for you. The first is, thank you for the presentation, very fun and creative attack surface. In your opinion, what can Android OS implement to prevent mobile phone vendors from leaving leftover debug secret codes?
Oh, okay, that is a really good question. So I think I can answer these questions from 2 aspects. Yeah. Later, if Zhang want to add on, please feel free to do so. So the first aspect is from the vendor's perspective. We suggest the vendors to remove all the apps or all the functionalities that just for testing in the factory before the mobile devices go to the market. And the question is regarding from the AOSP perspective, what can be done? I think one thing can be done is to add a permission. So which whatever app wanna set such intent, the intent we show in a presentation, there should be a guard there. So basically, I think that is the what AOSP can do. But I think the fundamental solution is for the vendors to remove those testers, those testing, debugging mode functionalities. Because even AOSP adding the permission are still possible for the vendors to remove the permission. Yeah, so that is no question from my side. Yeah, so Qing, if you have anything to add.
Okay, that's enough.
Okay, yeah, thanks.
Wonderful, thank you. We have another question. What Android permissions are required for an application to use secret code to invoke functions and craft Android intent to input secret code?
Yeah, so for this one, no, as we showed in the slide, if you still remember the code in Android manifest.xml, you can find there's no permission to protect those intent at all.
Okay, anything to add, Dr. Qing?
Thanks.
No, thank you.
Okay, we've got 2 more questions. The next one is, how do you analyze all the functions that handle secret code? Do you use any automation in the bug hunting process?
Oh, okay. So we mentioned it a bit in the very last part of the presentation. Basically, it's semi-automatic. We can do a automatic filtering. So basically, we scan all the manufactured file and find out the application which take or send the intent related to secret codes. And the next part for the logic, basically, I mean, when a secret code is received by an app, what will be done? That part was analyzed manually. Hope this answers your question.
Dr. Qing, anything to add?
Oh, okay. The thing, I don't have any to apply.
Okay, no worries. We've got one last one. It's more of a question not on the subject, but we'll ask it. It's from Anonymous as well. Xiaomi is ranked 2nd most popular mobile brand in 2020. Do you think Xiaomi will rebrand to Dami when they reach number 1?
Okay, that is really a question that I cannot answer. Qing, do you have any thought on this question?
I have no idea about this.
Yeah, it's very interesting question. But I mean, we also contribute a lot to Xiaomi's device security. But it's very hard for us to make an estimation on this. So sorry, but yeah, we are happy to contribute to the security of Android devices.
Right.
Any grants? Yeah.
And we're all happy to have you contributing and keeping us safer. Right. I think that's all the questions we have so far. We'd like to thank you again, Dr. Bai, Dr. Qing, for this wonderful presentation.
Thank you, Sriman, and thank you all the audience for your attention.